In today's class,
So we're gonna start with restricted values. Any value over 0 is something that doesn't exist. Whenever we have rational expressions with a variable in the denominator, we can find restrictions. But where is the restriction? As we know, a value over 0 is something that doesn't exist, so we need to clear the variable in the denominator to make the expression not equal to 0. As in the example, we can see that x cannot be 4 because if we substitute the variable, the value in the denominator would become 0, so we have a restricted value. Now I'm going to talk about wholes. When we have a rational expression and we expand it to its last, we can find values that cannot be graphed, so they become wholes, and I show you in the example. By factorizing the values on the numerator, we can realize that the values on the denominator are the same as the values on the numerator, so we can cancel out values and find the wholes. Now I'm going to show you graphically a whole, but first we need to find x and y. As we know, y is equal to 5x minus 2, we can substitute the values for x and for y. And for me it's easier to substitute variables x and y for 0. By doing this whole process, we will find the points in where our line will touch. Graphing the line. First we identify the point that we've just found, and then we do the line. But where is this strange hole that cannot be graphed? To find the hole, we will go back in time when we factorized. When we simplified the expression, we found out that some values were cancelled. The values that were cancelled will be the point where the hole is. Now we need to clear the variable x to get the exact point where the hole will be. Now that we know where the point is, we just put a little hole or an empty space in the graph where our point in x indicates. Now you know restricted values and holes. See you next class.